In our third video, let's look at integrals of natural log functions. So in this case, we see an ln of x squared over x dx. So we let u equal ln of x. Then du will equal 1 over x dx. So if we make the substitution, we will have the integral of u squared, and what's remaining is a 1 over x dx, which is actually identically equal to du. So this problem becomes the integral of u squared du, which is u to the third power times 1/3 plus our constant of integration, and then finally doing a back substitution, instead of u, we write ln of x, and we want to make sure we have the entire ln of x cubed plus our constant of integration. In the second problem, we will look at something that is similar to what we had in the first problem. At least it looks similar, but is actually a little bit different. So in the first problem, remember, we had the entire quantity ln of x squared over x dx. In this example, however, we have ln of x squared over x dx. So what we'll do is, as a first step here, we will use the properties of logarithms to rewrite this. Instead of ln of x squared, we can write this as 2 times ln of x over x dx. So now we're ready to do a substitution. We'll let u equal ln of x, then du will be 1 over x dx. So our problem then becomes making the substitution 2 times, and instead of ln of x, we replace this with u, and what we have remaining, 1 over x dx, is actually identical to du. So this problem becomes the integral of 2u du, which is 2 times u squared. We multiply by the reciprocal by 1/2 plus our constant of integration, and then simplifying this and back substituting, we have u squared, which is ln of x squared, plus our constant of integration. For the third example, let's look at the integral of 1 over the product of x times ln of x dx. If we make a u substitution and let u equal ln of x, then du will equal 1 over x dx. So now, making that substitution, we'll have the integral of 1 over u. If we look at what's remaining, we'll see that what's remaining is actually 1 over x dx, which is identical to du. So now we're looking at the integral of 1 over u du, which is the natural log of the absolute value of u plus a constant of integration, and then finally doing a back substitution. Instead of u, we replace u with ln of x. In this fourth example, we have something where it does not look like initially logarithms are involved, but we'll see that they are when we make our substitution. So first, let's notice that we have a 7x plus 7 in the numerator, so we can factor out a 7, and we'll have 7 times the integral of x plus 1 over 5x squared plus 10x plus 7. Now if we make the u substitution, letting u equal 5x squared plus 10x plus 7, we have that du will equal 10x plus 10 dx, or simplifying that a little bit, we'll have du equals 10 times x plus 1 dx. So now, going back to our problem, if we make the substitution, replacing the 5x squared plus 10x plus 7 with u, we'll see that what we have remaining is an x plus 1 dx. And over here, we see that x plus 1 dx is equivalent to 1/10 du. So we can replace the x plus 1 dx with 1/10 du. Now combining our constants out front here, we'll have 7/10 times the integral of 1 over u du, which is just the natural log of the absolute value of u, plus a constant of integration. And then finally, doing our back substitution so that our answer is in terms of x, we'll have a 7/10 times the natural log of the absolute value of 5x squared plus 10x plus 7 plus our constant of integration.